So in this next part, we are going to talk about uh, attacking the scissor cipher. Um, Obviously, no one uses the scissor cipher nowadays if they're really serious about encrypting their messages, simply because the scissor cipher is very easy to attack. It's almost trivial to attack. Um, and we're going to explore how we can if we are given an encrypted message and we don't know what that secret key is, how we can attack it and find out what the original message is, right? Um, and the the way to attack a scissor cipher is a straightforward brute force attack. We call it a brute force attack, meaning we're just going to try every single combination of keys until we find the right key. And why that works, especially for the scissor cipher, is because there's only 25 possible keys. Right? That's a really small number of keys. It's very easy to do a brute force attack, to go through every single possible key in the key space, and to look at it, look at the output, and figure out, aha, this is the one that makes sense, right? So we're gonna keep to our program, the program that we have written, and we're gonna add. We're gonna modify this. So either are you encrypting or doing a brute force attack, right? We are not gonna decrypt. We're just gonna do a brute force, and so 1 to encrypt and 0 for brute force attack. Okay, so if so when we're doing a brute force attack, we're not actually we don't know what the key is. So actually, I'm gonna bring this up to the first thing that we say: are you encrypting or doing a brute force attack? And so if it's encrypt, that's kind of misnamed now, but that's fine. If the user has entered um, 0, right? Then it's a brute force attack, and we actually wouldn't bother to ask him. Sorry, if the user enters a 1, then it's encrypt. We have to ask him for the key. Otherwise, we're not gonna ask him for the key, right? And then we have our scissor cipher again function. It's been functionalized. That's fine. We're not going to do anything to it. And I think this also kind of highlights the power of the function. When we were doing the decryption, notice that we actually did not have to change this function at all, right? We only had to change the key that was sent into the function to do the decryption. And similarly, when we're doing a brute force attack, we are going to keep this scissor function here intact. We're not going to change any part of it, right? We're going to be building on top of the function, right? So over here, if is encrypt is equal to 1, right? There's a mistake here. It should be a comparison operator, not an assignment operator. Then, if it's encrypt is equal to 1, then we're going to do the encryption, right? Else, and make a comment here, we are doing a brute force attack. Over here, we are encrypting with a key, with a secret key. Okay, so we are doing a brute force attack. if the user is choosing to do a brute force attack, what we need to do is we need to go to every single combination of key, which means we have a for loop for key in range of 26, right? Actually, we're gonna print out the key itself. Print using key. Okay, right? Using this key, the output will be, we're gonna send in to our it shouldn't be copied in text, but never mind. We're going to send it to our scissor function, the text, and the key. Okay, right. So let's let's go back and let's say we have this cipher text. We have no idea what the key is, because we are the snooper, right? We are not given the key. We are an outsider, but we want to know what the contents of this message is. So let's try running this. I am doing a brute force attack. Enter your text, right? This is the message, and then look what happens is that this for loop that we see here is going to go to every single key combination, of which there's only 26, and it's going to try out, okay, this is what it's going to look like if you're using key 0. It's not the right key, it's rubbish. If you're using key 1, it's not the right key, it doesn't make sense, doesn't make sense, doesn't make sense, doesn't make sense, it doesn't make sense, it doesn't make sense, and so on and so forth until you see key 20. You're going to see it makes sense, right? And actually, you're going to be wondering, no, wait, did we not use the key to be 6? Actually, the encryption was using key 6. It is key 6, but the decryption will be 26 minus 6, right? You can see we took that away, but the decryption is going to be going backwards in time, so it's actually negative 6, which is the same as positive 20, because we are doing this modular circular math thing, right? But the focus here is, I can try to fix the output here to say 6, but I think what's more important here is, yeah, actually I could just say 26 minus, okay, right, let's see whether this works. We are doing brute force attack, and this is our fantastic. We found out that the key is 6, and because that's the one that we produces the plain text, the real plain text. Right. Okay. Now I've forgotten what I was thinking about just now. Let's see. So yeah. So this is a brute force attack on the scissor cipher, and the reason why brute force attack works here is that the key space is really small. There's only 26 possible combination. When you're doing more sophisticated attacks, when you're doing more sophisticated ciphers, obviously a brute force attack is not going to work as well. But sometimes, like your emails, right? That your email account is protected by a password. What happens is that some people choose kind of very weak password. You have you have no idea just how many people out there chooses a very weak password, like password as a password, right? Or a word from the dictionary, and so that makes it very easy for people to use the brute force attack to try to just something they're trying to exploit the fact that some people uses weak password, and so they will like, okay, rather than attempting the entire key space of alphanumeric characters as a password, they're gonna attempt to use all the words in the dictionary, or they might have a list of very common passwords, and they'll try doing a brute force on those. It might not work, but it's a valid attack vector for them.